the date, sorry, 9/29, right? Okay, so for x equals 1 minus 2i, you start moving everybody to the left so we can make the right side equal to 0 and everybody's on the x side. So you can write it as a factor. X minus 1, right, equals to negative 2i. Then I would have to add 2i to both sides. Then we get x minus 1 plus 2i equals to 0. There's the other factor, okay? So these factors give us the quadratic equation, y equals x squared minus 2x plus 5. Do you see any imaginaries? No, this is how it works, okay? So since this is a trinomial, we're going to set it up as a 3 by 3. Okay? I'll put the red on top. It doesn't have to be. It can be on the left. Minus 1 minus 2i. And then I'll put the blue on the left. And then you start multiplying. What's x times x? X squared. X times negative 1 is negative x. This is also negative x. X times negative 2i. Okay, this is the order of how you write it. It's coefficient first, then the variable, then the imaginary. So it should be negative 2xi. Okay, are you guys even writing anything? Just eating? Negative 1 times negative 1 is positive 1. Negative 1 times negative 2i is going to be positive 2i. Positive 2i times x is positive 2xi. Negative 1 times 2i is negative 2i. And then the last one should be negative 4i squared. Now, hold up. I squared, what is that equal to? Negative 1. So I'm going to say negative 4 times negative 1 is positive 4, right? So I can combine positive 4 with 1. What does that become? 5. And then we have negative 2i with positive 2i canceling each other out. Then we have negative 2xi with positive 2xi canceling them out. And then we have our x, two negative x's being combined. I have negative 2x. And then our final x squared. Do you see it now? Okay. The reason that we can have those complex roots is because we have a quadratic formula that does exist. It just doesn't cross through the x-intercept. It doesn't have 0 roots. It has complex roots. So when you actually multiply, if you did this correctly, you would take these factors and multiply them to get the standard version of it. Okay. Questions? Okay. Conjugate pairs, this is tricky. They're not opposites. Repeat after me, they're not opposites. They're not opposites, okay? So imaginary roots come in pairs. Okay? So the root 3 minus 5i has a conjugate pair 3 plus 5i. They're not opposites. Okay? They're not opposites. The only part that could be considered opposites is the imaginary part. Do you see how the 3's remain as 3's? Which ones are the opposites? Just the imaginary piece. Imaginary pieces are the only pieces that are opposite because they need to cancel out. And they do cancel out. Okay? Ken, put that away. Okay. So let's try it. What's the conjugate of 1 minus I then? 1 plus I. Okay. What's the conjugate of negative 3i then? Positive 3i. And what's the conjugate of negative 3 plus I? Negative 3 minus I. And the conjugate of negative 5 minus 2i? Negative 5 plus 2i. Are these opposites? No, they're not opposites because if it were opposites, the first term would also change the sign. They're called conjugates. They're not opposites, they're conjugates. Okay? All right, any questions?